This video is for Chapter 12, Section 12.2 for the math activity Rotating, Reflecting, and Translating Figures on Grids. We'll visualize these motions and we'll use triangle and square pattern blocks. You'll find a small handheld mirror, any reflective surface, and tracing paper, patty paper or wax paper, helpful for this activity. In question 1, note we have a star grid. There's one shaded triangle and 11 numbered triangles. Using F as the center of rotation or G as the center of rotation, we can rotate triangle AFH onto triangle 5. Here's another view of that. Here we have a green triangle and it is rotating in stages you can see all the way onto triangle 5. F is the center of rotation here. If you put a piece of tracing paper over this grid, shade in the top shaded triangle, and then hold your pencil down at various vertices and rotate the shape, you can see where the triangle will land. You can try it for moving triangle AFH onto 5 using G as the center of rotation. Record your data for finding all of the places that the triangle can be rotated to. You can get to all of the numbered triangles except for one on a table like this. In question 2, we note that the shaded triangle can be flipped or reflected about this line that goes through AG, and you can see this reflection diagram is drawn here. You can also see that a mirror is handy here. If I held the mirror across this line, you can see that I could see that it would reflect the shaded triangle over onto triangle 1. Find the 7 other triangles to which the shaded triangle can be reflected, and record this on a table like this, and note that you don't have to use the existing lines on the diagram. You can go, for example, from vertex A to vertex R, and there's no line there already. In question 3, we move to our third motion, translation. The shaded triangle can be slid without turning to coincide with triangle 2. You can see it just slides down. This can be visualized by just thinking of sliding along this line H to B. Find 4 other triangles that the shaded triangle can be translated onto. So don't turn or reflect the triangle, just slide it. So again, you can put your tracing paper, and this time you can just slide the triangle down without turning. In question 4, we note that in activity 1, the shaded triangle could not be rotated onto triangle 8. However, it can be rotated about point G, remember that's the center, onto triangle 11, and then reflected about line CD to coincide with triangle 8. Find 3 other triangles that the shaded triangle can be rotated to and then reflected onto triangle 8. In question 5, we move to a square, and we have a rectangular array of squares. The shaded square, shown below, can be rotated about a lettered point to coincide with 8 of the 11 numbered squares. Find the squares where the square can be rotated and the point about where it can be rotated. So you can do the same thing with tracing paper. Shade your square hold down the various vertices and rotate the square to see where you can have it land and mark it in a table like this. In part B, we noticed that the shaded square can be reflected onto 5 of the numbered squares by reflecting about lines through lettered points. Find these and record them in a diagram. In part C, we note that the shaded square cannot be rotated onto square 2 by rotation about a lettered point, but it can be reflected onto square 1 and then rotated onto square 2. Describe how the shaded square can be reflected and then rotated onto square 7, 8, 10, and 11, and list those lines of reflection and points of rotation. That's it for Math Activity 12.2. It's interesting thinking about rotating, reflecting, and translating, turning, flipping, and sliding, fun words you can use with kids.